Hello, in this video I will show how to tune the worst performing loop using Proficy CSense. Using CSense Continuous Troubleshooter, I can import the worst performing control loop data and load the dataset for modeling. I can select the worst performing loop from the list of available loops, select its associated tags and select a range to import the latest data, and then I can specify a sampling period as needed. Once the dataset is loaded, I can start analysis for the dataset. After the dataset is ready for analysis, I can use the system identification modeling tool to create a process model from the data for the specific loop. I can specify the controller configurations here. Note that CSense can handle any controller configurations, and once you save it, the controller configurations are saved in the database. You can reuse the controller for future modeling. Here I am selecting a closed loop configuration and leaving the model type as auto. Next, I can perform step analysis by specifying the field mapping for data selection and selecting a range where I see the loop was stable. Here I am selecting the range where the loop was stable. As mentioned before, I have my controller configuration saved in the database and I am reusing it. Now I can specify the current or the actual proportional integral terms from the plant data. I can get this information from the loop shift performance monitoring report under the controller configuration. I'm leaving the other controller parameters as is. Now I want my settling time to be 120 seconds and I'm updating it, and also my time delay to be 0 seconds. I can now generate the model. Here I see that the model is created with an 84% fit. Also, I see that the model response is nearly accurate. Since I'm happy, I can save this model using the OK button. Now this model is saved into the database. Next, I can use the control loop tuning assistant to select the worst performing loop and tune it. I will use the latest process model that CSense generated to calculate the best PID tuning settings. I want the settling time to be 60 seconds and overshoot to be not more than 10%. I am keeping the PID tuning method to be auto so that CSense can recommend the best PID tuning settings. Now when I select the auto tune button, CSense provides the best recommended controller settings. I can see that the recommended settings is nearly close to what I wanted. The settling time is 57 seconds and the overshoot is 7.7%. Since I am happy with the recommendations, I can now save this recommendation to my loop database. Going back to my monitoring report, I can see the recommended tuning settings under the controller configuration. Now the settings are on the report, so anybody can view this report and see the current recommended settings for the loop. I can now go and update the settings in my PLC, and this will improve the loop performance. Here is the current shift report, and we can see that after applying the recommended settings, as the data comes in, the new settings have solved the variation and have resulted in a stable control that is nearly always within the acceptable control limits. I expect that when I come to the office tomorrow morning, the control performance of the loops will come back to normal level, that is 3%. I have been able to resolve the control loop issue in the plant quickly using Proficy CSense. In this video, I showed how to tune the worst performing loop using Proficy CSense. Thanks for watching.